Okay, 6.6, use proportionality theorems. We have a bunch of theorems to talk about today. We have the theorems and a bunch of examples also. First one is the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, here's my triangle, here's a line that is parallel to one side of the triangle. Here's my three sides of my triangle, this line is parallel to this side. Then it divides the two sides proportionally. So we have this line that's parallel to this side. These are the other two sides that get divided proportionally. So if I know these two lines are parallel, then here's the proportion that we're talking about. RT over TQ, RU over US. Try to use some colors here so you can kind of visualize where the parallel lines are and what is being divided proportionally. So this side and then this side. So let's look at the converse. Taking the exact opposite, if a line divides the sides of a triangle proportionally, then we know that it's parallel. So looking at my pictures, and I didn't highlight this one the way I did the first one. If I know that RT over TQ and RU over US, if I know that this is an accurate proportion, then I know that these two lines are parallel. So it's the exact opposite of what we just talked about over here. Look at my first example. It says determine the value of x so that these two lines are parallel. DE is parallel to BC. So in order for these two to be parallel, these sides have to be cut proportionally. So using what we just talked about with those two theorems, I can say x minus 4 over 18 equals x minus 5 over 15. Make sure that's set up accurately. If you see that a little bit differently, as long as your cross products are the same, you're okay. So of course we're going to multiply cross products, 15 times x minus 4 and 18 times x minus 5. Remember we talked about that is a distributive problem, so be very careful you don't make mistakes on that. Distribute, I move the 15x over, I move my 90 over, divide by 3, and x is 10. If I went too fast, pause that and look at that in a little more detail. The next theorem, if we have three parallel lines, and I'm going to add this in here. We have three parallel lines. In this case, we have R, S, and T are all parallel. And they intersect two transversals. These red lines, L and M, are the transversals. Then they divide the transversals proportionally. This has a lot going on here. Concentrate on the parallel lines doing the cutting. Here's my transversals. So if I know that I have three parallel lines and I see two transversals, I know this relationship works. So look, I tried to use colors again. UW over WY, VX over XZ. So kind of visualize where that's coming from because the picture isn't always going to look like this. Look at my example up here. So we're finding x. I have three parallel lines. These two lines are my transversal, which means that it does cut the transversals proportionally. Remember, these are my transversals that are being cut. So we're going to do 5x over 3x, that's my first ratio, and then 8x over 60 is my second ratio. From here, you know to do cross products. Be careful with your cross products. This one, 60 times 5x gives you 300x. This way, be careful. 8x times 3x gives you 24x squared. X times x is x squared. Don't make a mistake on that. From here, my first step, I divided by x to simplify. That gives me 300 on the left and 24x on the right. Divide by 24 and x is 12.5. One more theorem. If a ray bisects an angle of a triangle, looking at my picture, here's my triangle ABC. This ray right here, CD, bisects this angle. I can see that with these markings. So CD cuts this angle exactly into two equal angles. If that's true, then it divides the opposite side proportionally. And look at what's given to us. I know that this cuts this angle exactly in half. Then, this one is a little bit tricky. AD over DB equals CA over CB. Be careful that you don't set that up incorrectly. We have an example over here that's similar to that. So I know this line bisects this angle just by looking at those symbols. Because it bisects the angle, I'm allowed to set this up using the proportions that we just talked about. So looking at what's given to you, I have 8 over 28 minus x. If this is 28 and this is x, this segment here is 28 minus x. Let me write that a little neater. So 8 over 28 minus x, then 24 over x. You need to pause this a second and go back and look at your notes from the theorem we just talked about. This lines up exactly with what we just said. Then using our cross products and solving, x is 21. Again, if I went too quickly with that, go ahead and pause and make sure that that makes sense. Your homework is posted online. Go ahead and get started on that.